All right, we're going to go through the warm-up and then we'll talk the quiz review. So this says, for number 1, find the value of x that makes P parallel to Q. Remember yesterday we talked about there was how many ways to prove that lines are parallel? 6 ways. What are they? What do you think? Corresponding angles, postulate, converse, which says what?
That the boxes that they
if the angles are corresponding,
they're congruent.
If they're congruent, then the lines are parallel. Yes? So if corresponding angles are congruent, then the lines are parallel, right? No. What's another way? Alternate interior angles theorem. Converse, which says what?
if the alternate interior angles are congruent, then the lines are parallel.
Good. Next one. Alternate exterior angles theorem. Converse, which says?
If the interior angles are congruent, then the lines are parallel.
Good. Fourth one.
This is the
consecutive.
So consecutive interior angles theorem. Converse, which says?
If the consecutive angles equal 180, then they are parallel lines.
Good. If the consecutive interior angles are supplementary, then the lines are parallel. Or 180. 180 is fine. That works. Next one. Transitive property of parallel lines, which says?
If 2 lines are parallel to each other,
Good. 2 lines are parallel to each other, then they are parallel. If they are each parallel, sorry. If they are parallel to a third line, then they are parallel to each other. Last one.
Is it with the plane?
the one that you forgot.
The one with the plane, right? If a plane.
Of course.
Perpendicular. If 2 lines.
Wait, what about the plane thing?
Well, they had to be coplanar. So if 2 coplanar lines are perpendicular to the same line, then they are. Sure. That's on your notes yesterday. That is not great in your brain yet. Get it there. Okay? 6 ways. So the last one, if you remember from the homework, I actually did I went over the homework example yesterday. The proof that we did is that theorem, which is just the transversal perpendicular line theorem, which says that. Okay? But we did that example. You can either write it all the way out or you can learn the names of these. Okay? But those are the 6 ways to prove lines are parallel.
Can you give an example of 6?
Yeah, if there was 2 lines and this one's perpendicular and this one. So it's if M and P. I think this is what I did yesterday, right? If M is perpendicular to P and N is perpendicular to P, then M is parallel to N.
So isn't perpendicular similar to corresponding?
So you can go through the process of corresponding, but you'd have to say that equals 90, and then the other one equals 90, and then they equal each other. And if they equal each other, then corresponding angles. But you could go there in one step if it's a right angle.
And how would you put that in the...
So givens would be that they're perpendicular, right? So I would say that whatever that angle is, let's say this is angle 1. Angle 1 equals 90, definition of perpendicular. Angle 2 equals 90, definition of perpendicular. Angle 1 equals angle 2, substitution. And then the lines are parallel because the corresponding angle is postulate converse. It's just that now you can get there in one step instead of having to do that. Yep, as only if they're perpendicular, but yes. Sophia.
What is 6 called though? What is it?
It's called the perpendicular transversal theorem. If you look, this is what that is. So this is called the perpendicular transversal theorem. This is that last one. All right, so let's go back to... All right, so number 1 said find the value of x that makes P parallel to Q. So if these angles are called what? What's the relationship? Alternate interior. And if alternate interior are blank, then the lines are parallel. What's the blank? Congruent. So I would say 2x plus 43 would have to equal 3x. Subtract, and I get x has to equal 43. So if x is not 43, they're not parallel. If x is 43, they are parallel. Number 2 says, can you prove A is parallel to B? And if so, what theorem would you use? Can you?
Yes.
Yes, and what?
Alternate interior angles.
Alternate interior angles. Theorem. Converse. Which again, if you don't know the name, you're going to write out if 2 angles, or if alternate interior angles are congruent, then the lines are parallel. All right, 3 says which lines are parallel. So I only have the angles inside these. I can either say that those are my parallel lines, this is my transversal, or this is my transversal. So if I add these together, what do I get? 180. If I add these two together, I get 180. So if they're same side interior or consecutive interior like these are, then which are the parallel lines?
FG is parallel to ED.
Good. Wait. Nope. EF. Parallel to DG. Okay? Look at what happens if I turn this, right? You might need to do this.
I mean, it looks like this.
If I'm looking to see if the red lines are parallel, then these two would have to add up to 180, and these two would have to add up to 180, and they're not, right?
Yeah.
So there might be some rotation of your papers. That's fine, like especially in a quiz.
Everything has to add up to 180.
Yep.
Can you explain that again?
Since they're consecutive, then you add up to 180.
So the same side interior, if I'm looking at EF and DE, would be this angle, these angles, and this angle. Those add up to 180. If they add up to 180, then the lines are parallel. But if I look at the lines from this way, in order for these lines, this one and this one to be parallel, then these two and these two have to add up to 180, and they don't. Yep. Okay. 4 says in the figure, if HJ is parallel to KL, so HJ is here, is parallel to KL, and KL, which is this one, is parallel to MN, what can you conclude? And why is that? Good.
Why would EF parallel to EG? You gotta rotate.
Tomorrow's quiz is covering 3.1 to 3.3, okay? And 3.1, it was all the definitions of parallel lines, skew lines. Oops, if I spelled
So
correctly.
you write this on the board?
Wherever you want to write it. Perpendicular lines. So you're going to get vocab-based questions there, true or false, sometimes always never, or if I give you a diagram, identify types of lines, okay? And then all the special angles came out in this one. Alternate interior, alternate exterior, consecutive.
Wait, I thought that was in 3.2.
No, the definition of them came out in 3.1, and then the properties, if they're parallel, came out in 3.2. What am I missing? Corresponding. So these lines didn't have to be parallel. So the lines aren't necessarily parallel with just the definitions, right? Alternate interior could be 2 and 7, 4 and 5. That's hard to read, sorry. Alternate exterior would be 1 and 8, 3 and 6. Consecutive interior would be 2 and 5. Oops. 4 and 7. And corresponding 1 and 5, 2 and 6, 3 and 7, 4 and 8. So you want to be able to identify those special kind of angles, God bless you, from a diagram. These are not congruent supplementary yet because those lines are not parallel. So all that stuff happened. We also talked about transversal, but all of that stuff happened in 3.1. Then came 3.2, which was all the theorems about parallel lines. They all started the same way. If two parallel lines are cut by a transversal, then, and there's 4 of them, alternate interior theorem says alt interior angles are congruent. Then there was alternate exterior theorem which said alternate exterior angles are congruent. Corresponding angles, but this is the postulate, said corresponding are congruent. And then the last one was consecutive. Well, and not necessarily that order, but so now you were given that the lines were parallel, and then you made those assumptions. So if they're parallel, you might have an expression, you set them equal to each other, so add them up to 180. You might have a part of a proof that has these. If the lines are parallel, then what can you know about those, which we're going to get to in a minute. You either need to know the name or you know what it says. I will take either one.
So say if we have to prove, like, you give us a given and what we have to prove, can we just say like corresponding posh, or do we have to?
Corresponding angles postulate. Yeah. Yeah, you'll see. I'm going to, like, that's why I'm kind of cutting through this now, is I have a couple proofs for you guys to practice, and we'll work through them. So then 3.3 was what we started the warm-up with, right? So this was the if all these angles, so if alternate interior, congruent, alternate exterior, congruent, corresponding, congruent, and consecutive, supplementary, then the lines are parallel. These are all the converses. So the names above plus the word converse. And then we had transitive, property of parallel lines, which says if two lines are parallel to the same line, they are parallel to each other, and perpendicular, transversal, oops, theorem, which said if two coplanar lines are perpendicular to the same line, they are parallel. Yep.
Consecutive interior,
Are supplementary.
but that would be just consecutive. How would it be consecutive interior theorem converse?
Yes.
Okay.
Yeah, so it's all of these names with the word converse added on. It would be alternate interior angles, theorem converse, alternate exterior angles, theorem converse, corresponding postulate converse, and consecutive interior angles, theorem converse.
Do you have to say interior for consecutive?
Yeah, that's the name of them. This should be supplementary. Thank you, Sophia. Okay, so corresponding alternate interior and alternate exterior are congruent, but consecutive interior are supplementary. Thank you very much. Okay, this is again, this is the class kick code. Okay, let's get in there. Let's do as many of them as we can. To do this proof, but this is one way to do this proof. Okay, if you are given that these lines are parallel and that these lines are parallel, and I want to get from 1 to 16. 1 and 16 do not lie on the same transversal, so I got to get to that point. So this example, I went from 1 to 5 using the corresponding angles theorem. Then I went from 5 to 16 using alternate interior angles theorem. Corresponding angles postulate. And then alternate interior angles theorem. And then transitive is the better choice, but I would have taken substitution as well. If 1 equals 5 and 5 equals 16, then you can go from 1 to 16, and that's transitive. This is, again, I want to stress, this is not the only way to do it. I think it was Leo. He went from 1 to 9, corresponding, 9 to 16, alternate exterior, 1 to 16, transitive. Still works, okay? Connor.
Why is it transitive?
Because you're basically taking these two statements and putting them together. If 1 equals 5 and 5 equals 16, then 1 equals 16.
I thought you were talking like the transitive.
not the parallel lines. Just the transitive property of congruence is what this one would be.
Is it
Chia.
okay if we did like, I did 1 to 4, because that's a
Vertical angle.
And then corresponding.
Then you did 4 to 8?
4 to 16.
No, 4 and 16 are not in the same transversal. So if you do 1 to 4 vertical angles,
4 to 8, yeah.
then you have to do 4 to 8 corresponding. Then you have to do 8 to 16 corresponding again. Yep.
I went from 1 to 8 and then 8 to 16.
1 to 8 alternate exterior, 8 to 16 corresponding, 1 to 16 transitive. That works. Okay, I gotta go to the next one.
And like, I know what the last is. I got them wrong. How can you tell?
If we're talking about a single object, this object is, which we're talking about angles right now, right? This object equals this object, and that object equals a third, so the first and the third equal each other. That better option is transitive. If you're saying a value, like angle 1 equals 90 degrees, angle 2 equals 90 degrees, so angle 1 and angle 2 are equal to each other, substitution, because you're doing a value. If it's in an equation, like 2a equals 10 and a equals 5, then 2 times 5 equals 10, substitution, and only substitution. Transitive doesn't work on that. So, don't stress about it too bad. I would have taken either. The better option there is transitive because you're talking about physical objects, angles that equal each other with no value. Okay, then came this one. Okay, the first one is yes. Corresponding interior angles, postulate. Converse. This is important. This time we're trying to prove the lines are parallel. So it has to be the converses.
Wait, you said 1 is corresponding? Or?
One is, oh, no, I didn't, that's right. Yeah, I was right the first time. Sorry. Consecutive interior angles, theorem. Converse. Second one is yes. This time it's the corresponding angles, postulate converse. The third one is no. First of all, there's no link between where the 75 is and the 115. But even if you used vertical angles and then tried to use consecutive interior, they are not supplementary. So it's no. The fourth one is yes, alternate exterior angles, theorem converse. The fifth one is no, those are only vertical angles. Those don't prove lines parallel. The sixth one is yes, corresponding angles, postulate converse. Again, all of these have the word postulate in them because we're proving the lines are parallel. Brayden.
So in the answers, I got them right, but like I put before theorem, I put the like
Converse theorem, converse.
or,
Oh, you don't need it. You can either have the name or the reason. You don't need both. But you can, if you don't know the name, you can write it all out. So it doesn't matter. You just don't need it. Okay, this one said 1 and 6 are supplementary. Prove A is parallel to B. So this proof says that 1 and 6 are supplementary, and you're trying to prove that A is parallel to B. So again, if you go through the ways to prove that lines are parallel, you should remember that there's one about supplementary, which basically says that if two consecutive interior angles are supplementary, then the lines are parallel. So you're going to have to work through this one, trying to figure out how to get that, possibly because 6 is in it, 4 and 6 are supplementary. If those are supplementary, then the lines are parallel. So as usual, we start with our given, angle 1 and angle 6 are supplementary. And again, that's given. So one way to get from 1 and 6 into 4 and 6 is that there's a relationship between 1 and 4. And that is that they're congruent. Angle 1 is congruent to angle 4. And that's the vertical angles theorem. So now, if 1 plus 6 is 180, and that's the definition of supplementary, and 1 equals 4, I can take the 1 and replace it with 4. So I can say angle 4 plus angle 6 equals 180. And that's substitution. So I can say 4 and 6 are supplementary. And that's the definition of supplementary. And then I can say line A is parallel to line B, and this is the consecutive interior angles theorem converse, which says that if consecutive interior angles are supplementary, then the lines are parallel. Okay, looking at the next one, this one says that given the measure of angle 1 is 53, so this is 53, and 2 is 127. Again, you're trying to prove that the lines are parallel. So start with your given. Measure of angle 1 equals 53. Measure of angle 2 equals 127. And what you should notice about 53 and 127 is that they actually add up to 180. So we're back with the same kind of pattern where we want to try to prove that things are supplementary. So you can do this a couple of different ways. One is this way. I can say that those are given. I can say that 2 and 3 are also supplementary because linear pair postulate. So angle 2 and angle 3 are supplementary, which is the linear pair postulate. 3 would say the measure of angle 2 plus the measure of angle 3 equals 180, and that's the definition of supplementary. Then I can say that I can actually use the value, since I'm trying to eventually link like 3 to 1, so showing those as congruent because those would be corresponding. I can replace 2 with the value that 2 is, which is 127. So I can say 127 plus the measure of angle 3 equals 180, and that's substitution. And then I can subtract that 127 away from both sides, and I get the measure of angle 3 equals 53 degrees, and that's subtraction. Property of equality. And then I can say, since the measure of angle 1 equals 50 degrees, I can say measure of angle 3 equals measure of angle 1. That's substitution. And the last step, J is parallel to K because the corresponding angles, postulate, converse. Okay, next one says, given the measure of angle 1 is 135 and 2 is 45, I'm trying to prove that N is parallel to P. So I can actually just get from 135 across here to that 3, show that those two are supplementary, and then use the consecutive interior angles converse. So start with my given. 1 is 135, 2 is 45. And then these are vertical angles. So angle 1 equals angle 3, and that's vertical angles theorem, which means angle 3 equals 135. That's substitution. And then if this is 135 and that's 45, I can say that angle 2 plus angle 3 equals, are supplementary, which is the definition of supplementary. And then I can say that line N is parallel to P, consecutive interior angles theorem, converse. Don't forget that the quiz review is available on Canvas. The solutions are posted. Most of this class kick covered 3.2 and 3.3, but you definitely want to review the definitions from 3.1, and there's extra practice problems on there. And then your Quizlet link is also on the module underneath the quiz review and quiz heading. Good luck studying.